Hello everyone, and welcome to another GIS statistics tutorial video. And in this video, I want to continue our discussion on the sort of fundamental statistics that I hope that you already know going forward into the semester. And in specific, what I want to talk about in this video is one of the most basic pieces of descriptive statistics. So these are the statistics that describe data, and that is what's called the mean. And so the mean you can sort of think of conceptually, or sometimes you'll see it called the average. Right? You can sort of think of this as what you might think of as the expected value. Right? And what that sort of means is that if you were to pull an observation out of a sample at random, right, you would expect it to be closer or close to this average or the mean. Right? So if you were putting a bet down on drawing a number out of a hat, and you knew the mean of all of the numbers that were in that hat, right? The best place for you to place your money would be on that mean, because again, that's sort of the center of the data set, or it's typically the center of the data set, and it generally represents the value that you're most likely to see, or the value that most numbers are going to be closest to. Right? So you can see it's sometimes called the expected value, and it's a measure of the center of the data set. And it's also an indication of what values will look like. Right, again, right, knowing nothing else, this is generally an indicator of where the center of the data set is, and it's a general indicator of what the values are expected to look like. If you had a mean of 100, right, you would expect most of the values to be closer to 100 than, say, 0. If you had a data set where the average was 10, right, you'd expect most of the values to be closer to 10 than 100. So what does this look like mathematically? Well, in equations, you're most often going to see the sample statistic of the mean to be denoted as an x with a bar across it. And then you're going to see equations written something like this. 1 over n times this thing here. This is called the summation. So this just means add everything up of x sub I. X sub I is the x value of the ith observation. And we'll get to what the ith observation means in just a second. And then n is the number of observations. Okay. So what I've done is I've copied over a random set of 8 numbers here, and I want to walk through this calculation on these 8 numbers. And so what I want to do is, first of all, what does xi mean? Right? Xi is the x value of the ith observation. So if I were 1, right? So if I equals 1, right? If I equals 1, right? X sub I is going to be the x value of the ith observation. So we're going to go up to here, right? Each one of these rows is an observation. So if I equals 1, right, the ith observation when I equals 1 is going to be this right here. Right, this right here, this is x sub I when I equals 1, right? And you can imagine going down the list, right? This value right here, right? That is going to be 1, 2, 3, 4, 5, right? This is x sub I when I equals 5, right? And so you can imagine, right, summing up. So with this right here, this summation of x sub I is saying, is basically saying add up all of the x values in the data set. All right, so we would have 6 plus 6 plus 1 plus 4 plus 2 plus 3 plus 7 plus 2, right? So this top part here, right, this is the summation of x sub I. And then we're multiplying it by 1 over n, which is the same as putting n on the bottom. And n is the number of observations. So in this case, we have 8 observations, so we're going to put an 8 on the bottom, right? So if we sum all of that up, we get 31 on the top and 8 on the bottom still. And this is going to be equal to 3.875, okay? And again, right, this right here, so this is x bar, right? This is the expected value or the center of the data set, or a measure of the center of the data set. It's the value that most things are going to be closest to. Now, this particular example isn't a very good example of this being, the value that most of the values are closest to, because we're going to talk about variance in a second, right? This data set has a very high variance. It also has a very small sample size. We only have 8 measurements. But again, in general, right, this average is going to be sort of a rough indication of the center of the data set, and it's going to give you an indication of what the values are going to look like. So hopefully this makes sense. Hopefully this was a review. If any of this doesn't make sense to you, I encourage you to pause the video, go back, rewatch the parts you're confused about. And as always, please reach out. Thank you.